Today we're going to be learning how to graph linear equations. A linear equation is a type of linear function. And remember, a function is where only one member of the x is paired with one element of the y. And the graph of the linear equation, since it's a function, it's going to be a straight line. So every time we graph these on the coordinate plane, you're going to get a straight line. And a linear equation represents a situation with a function rule. So since it's a function, we're going to have some type of rule associated with it. And so there's 3 steps to graphing a linear equation. The first step you have to do is, given the rule, you're going to create a table. You may remember these as input-output tables. The next thing you're going to do is plot the ordered pairs from the table. And then the third thing you'll do is you'll connect the points to form a straight line. So let's start practicing a few of these. The first function rule says y equals 2x minus 3. So we need to create a table, and I've already done that for you here. We've got our input values, which is x, our domain. In the middle, our rule is going to go, which is going to be 2x minus 3. That's our rule. That's the math that we're going to have to do. And then once we plug in our input, our x value, to our rule, then we'll get an output value of y, and then we'll have once we've got an x and a y, we'll have an ordered pair. So what should we put for our domain? Typically, what a good idea to do is to pick a negative, 0, and maybe 1 or 2 positives. So today I'm going to pick negative 1, 0, 1, and 2. And you can pick those numbers every time if you choose. Negative 1, 0, 1 will give you kind of a nice spread on most graphs. Sometimes you have to pick a little smaller or larger numbers, but for the most part, if you pick negative 1, 0, 1, you're in good shape. So now every time I see x in the rule, I'm going to plug in my input values. So I've got 2 times negative 1 minus 3. Then I've got 2 times 0 minus 3. 2 times 1 minus 3. And 2 times 2 minus 3. So now what I have left to do is that I've put my input values in. I need to do the math to get my output, my range. So I'll do for the first one, 2 times negative 1 is negative 2, and negative 2 minus 3 gives me a value of negative 5. 2 times 0 is 0, minus 3 is negative 3. 2 times 1 is 2. 2 minus 3 is negative 1, and 2 times 2 is 4, and 4 minus 3 is 1. We're remembering to do order of operations for these. I multiplied first and then subtracted. And so now that I have my ordered pairs, I'm going to go ahead and come over to the graph, and I'm going to use the ordered pairs, my input and my output, to graph a line on my coordinate plane. So my first ordered pair is negative 1, negative 5. So I'll count over to negative 1 and down to negative 5 and plot my point. My next ordered pair is 0, negative 3. So I'll go over none and down to negative 3 and plot my point. My next ordered pair is 1, -1. So I'll go over to +1 and down to -1 and plot my point. And then my last ordered pair is over 2, up 1. And so as you can see, I'm going to connect my points, and it makes a straight line. So I know I graphed my linear equation correctly because I have a straight line. If my line wasn't straight, then my math is wrong, so I'd have to go back to my table and look at my values and see where I messed up. So then the last thing I'm going to do is identify the domain, range, independent variable, and dependent variable. Now the domain, remember, is all your x values. So that's basically just my input from my table. So it's going to be -1, 0, 1, 2. My range is all my output values, my y's. So those are the y's that I calculated. -5, -3, -1, and 1. And then for my independent variable, I have to go back to my function rule. Remember, independent variables in the function rule is x, and the dependent variable in the equation is always y. So now let's go ahead and we're going to take a look at the next example. So this time the rules is -3x. So I still have my table and my graph. So we'll go ahead and put in my rule, which is -3x. I'll be multiplying this time. Still going to use 4 values, -1, 0, 1, 2. I'll go ahead and plug in my values. So every time I see x, I'll put in my input of -1. This one's going to be 0, 1, and 2. Now it's time to do the math, so I'll multiply all of my input values by -3. -3 times -1 is +3. -3 times 0 is 0. -3 times 1 is -3. And -3 times 2 is -6. So now that I have my input and my output, x and y make ordered pairs, so I'll come over to my graph and I'll graph my linear equation. So I am going to go over to -1 and up 3. Then I will go over 0, up 0, so that's the origin right in the middle. Then I'll go over 1 down to -3. And then I'll go over to 2 and down to -6. And I will connect my points, and it makes a straight line. So there's the graph of the equation y equals -3x. Now just like I did before, I'll identify my domain and range. So my domain is all my x values, -1, 0, 1, and 2. My range are all my output values, and this time I'm going to go ahead and write them in numeric order. You'll most likely see these written from least to greatest. Remember, my independent variable is in my function rule, that's x. And my dependent variable is also in the function rule, and that's always y. So the next problem we're going to be looking at is where you're given a table and you've got to find a missing value. It says Alana is creating a table of values to graph the equation 2x plus 3y equals 9. What is the missing value? So the only one that we're going to be focusing on is this right here, this input, and we want to know the output. And so what we need to do is use the equation and plug in the input value, -3. So I'll write the rule. And you're probably noticing that this is looking a little different than y equals, so that's why I wanted to go over it with you to show you how to do it. So my input value is still going to be negative 3 for x, so I'll put in 2 times negative 3 plus 3 times y equals 9. Now we're going to solve for y. So I'll do 2 times negative 3, which is negative 6, plus 3y equals 9. Now this problem right here is a two-step equation, and so I'm going to solve it like so. If we have a negative 6, the opposite of a negative 6 is positive or adding 6, so I'll add 6 to both sides. My 6's cancel, but I still have 3y, and 9 plus 6 gives me 15. And then the last step would be to divide by 3. Then I've solved for the y value. And 15 divided by 3 is 5. So if your input value is negative 3, then your output value is 5. Now, the other kind of problem that I want to show you today is when they just give you a question. This is what you'll probably see most likely on your test quizzes and your SOL test, when they're asking what is the graph of an equation. And in this case, the equation is y equals x. So remember, the first step is to simply make a table. So we'll have to draw one in. You'll have to draw your own most of the time. And so we'll once again pick our input values. So I'll simply do negative 1, 0, 1, 2. Then the next part is the rule. Well, you're going to notice that in this problem, there's really no math. It just says y equals x. So that is our rule. Whatever x is, y is going to be the exact same value. So if x is negative 1, if they're equal to each other, then y has to be negative 1. If x is 0 and they're equal to each other, then y has to be 0. And the same for the input of 1, and the same for the input of 2. So now you've got your ordered pairs. So we'll go over to the graph here, and we're going to plot over to negative 1, down 1. Next we'll plot 0, 0. Then we'll plot 1, 1. And then last ordered pair we'll plot is 2, 2. And then we'll connect our ordered pairs on the graph, and it makes a straight line. So that's the graph of the linear equation y equals x.